Welcome children to our second Mathematics Flipped Classroom lesson. Today you are going to learn about numerators and denominators. After watching this video, you should be able to use the terms numerator and denominator to describe parts of fractions. Write a fraction given the numerator and denominator. Last but not least, solved word problems relating to numerators and denominators. Are you ready to start learning? Look at this given shape. This shows a circle. How many parts is this circle divided into? Let's count. 1, 2, 3, 4. Yes, this circle has been divided into 4 equal parts. Now, I am going to shade some parts of this circle. How many parts of this circle are shaded? Let's count. 1, 2, and 3. 3 parts of this circle are shaded. How do we write out this fraction? Let's write 3 out of 4. Now, 3 out of 4, or 3/4 of this circle, is shaded. This 3 over here, there's a special name for it. It's known as the numerator. While this 4 over here is known as the denominator. Let me write down. Yes, the denominator. Numerator refers to the parts required. In this case, the parts required are the shaded parts, the yellow parts, and so 3 is the numerator. 3 is the numerator from this fraction 3 out of 4, 3/4. While denominator refers to the total number of parts in the whole. In this case, just now we have already counted, they are altogether 4 equal parts in this circle. Hence, 4 is the denominator, and 4 is the denominator from this fraction 3 out of 4, 3/4. Now, my next question to you is, how many parts of this circle, how many parts of this circle is or are not shaded? Well, take a look. Let's count. 1. One part of this circle is not shaded. And how do we write out the fraction that represents this unshaded part? We are going to write it as 1 out of 4, or 1/4. Once again, children, 1, this number here, is the numerator. Yes, very good, numerator. While this 4 over here at the bottom here is known as the denominator. Yes, denominator. Alright, so 1 is the numerator because numerator refers to the parts required, and in this case we are talking about the unshaded part. The required part is the unshaded part. So hence 1 is the numerator. 1 is the numerator from this fraction 1/4. While 4 is the denominator. Denominator refers to the total number of parts in the whole, in this whole circle. So just now we counted 4, that's why 4 is the denominator. Do you understand this now? I will show you more examples. Next, look at this given shape. What does it show? Yes, it is a square. Now, how many parts has this square been divided into? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Yes, this square has been divided into 9 equal parts. Now, I'm going to now shade some parts of this square. How many parts am I going to shade? I have shaded 3 parts of this square, of this shape over here. So, okay, let's count just to be sure. 1, 2, 3. Yes, 3 parts of this square are shaded. So, I'm going to write out this fraction representing the shaded parts as 3 out of 9. 3/9. Now, 3 out of 9 means that 3 parts of this shape over here has been shaded, while the total number of parts is 9. So 3 is known as the numerator. Yes, numerator. While 9 over here refers to the denominator. Yes, denominator. Alright? Once again, children, just now you have already learned that numerator refers to the required parts. In this case, I am asking about the shaded parts, those pink parts over there, the shaded parts. So that's why 3 must be your numerator, because just now we counted there's already 3 shaded parts. While denominator refers to the total number of parts in a whole, and just now we have counted all together, there are 9 equal parts. Now, how about if I ask you this question? What is the fraction representing the unshaded parts? What would your answer be? Now, let's count. How many unshaded parts do we have all together? 1, 2, 3, 4, 5, and 6. 6 parts of it are unshaded, while those 3 over there, they are shaded. So 6 should be your numerator. Yes, representing, remember now we are looking for the fraction representing the unshaded parts, right? And what is the denominator? Just now we counted all together. There are 9 equal parts. So you write 9 over here. So children, once again, 6 is the numerator. Yes, numerator. While 9 is the denominator. Alright? Okay? So I hope you understand this. Now let's look at the very last example. Now, how many parts is this rectangle divided into? Let's count. 1, 2, 3, 4, 5, 6, and 7. This long rectangle has been divided into 7 equal parts. Now, once again, children, we are learning about numerator and denominator. Let me write out these two words again. Numerator and also denominator. Can you guess what my question is going to be? Yes, my question is going to be, what is the fraction representing the shaded parts? Let's count. How many shaded parts do we have? 1, 2, and 3. Only 3 parts in this rectangle are shaded. So the numerator always refers to the required number of parts, and in this case, we are now looking for the number of shaded parts. So your numerator must be 3. Let's write 3 over here. While denominator, recall, just now we talked about denominator referring to the total number of parts. So just now we have already counted 1, 2, 3, 4, 5, 6, and 7. Just now we counted, they are all together 7 equal parts. So let's write denominator as 7. Alright? So this fraction over here, 3/7 is the fraction representing the shaded parts. Shaded parts. Alright? Shaded parts. Okay, now I'm going to ask you the next question. Are you able to predict my next question? Yes, my next question is actually, what is the fraction representing the unshaded parts? So let's take a look. If the total number of parts, just now we counted already, it's still there anyway, it's 7. Let's write out 7. But now children, numerator won't be 3 anymore, because now we are referring to the required parts would be the unshaded parts. So let's count all together how many parts are unshaded in this rectangle. Let's go. 1, 2, 3, and 4. Yes, only 4 parts there are shaded, so your numerator must be 4. So in this case, children, 4 out of 7, 4/7 is the fraction representing the unshaded parts. Alright, unshaded parts. Okay, do you understand? Alright, now let me move on to the last slide, which is the word problems section already. Next one. Now I have a question for you. Let me read the question now. If the numerator of a fraction is twice as large as 3, while the denominator of the fraction is 9 more than the numerator, what is the fraction? Okay, let me show you how this is to be done. Now we talk about the numerator over here is twice. Twice means how many times more? 2 times more than 3, right? Alright, so twice as large as 3. Do your usual highlighting of keywords. And the next one says the denominator of this fraction, however, is 9 more than the numerator. Okay, so how do you do this question? Okay, the first step should be, let's settle the numerator. So what is what is twice as large as 3? So take 3 multiplied by 2. What is 3 times 2? It is equals to 6. So that is the numerator of your unknown fraction. How about the denominator of the fraction? The denominator is 9 more than the numerator. Well, we know the numerator is already 6, so the next step is pretty straightforward. The next step should be 6 more than 9 will be 6 plus 9. And what is 6 plus 9? Is actually equals to 15. Okay, so children, sorry about that. Let me try to write back my 6. Okay, so now children, what is the fraction? So your answer should be 6 is the numerator. Denominator is always at the bottom, referring to the total number of parts. So that would be 15. Right, so your answer is 6 out of 15. Alright, so I hope you understand how to do such questions. You will see more examples in your in your mathematics workbook. I will see all of you back in class soon. That's all I have for you today. If you have any questions, please feel free to ask me when I see you in class on Monday. Alright, that's it children. Goodbye.